separates a pair of empty parentheses on the left from a body of code on the right. All right, so this body of code on the right is the body of the function that we're talking about here. And these parentheses on the left are where you put the arguments to the function. In this case, there are none, so we just put an empty pair of parentheses. All right? And for historical reasons, we call this kind of thing a lambda expression or a lambda function. Lambda being a letter of the Greek alphabet. Okay, so we'll start up the thread. The thread's constructor takes the function that's going to run on the thread, and then we just say thread start. Now we're moving along at warp speed, and suddenly he's dead. So, the beautiful simplicity of this is appealing. The danger of it is there's nobody watching to see how many threads you're creating. Nobody's going to stop you and say, no, you can't have any more because our resources on the machine are getting a little thin. What if you can't create a thread? What if the operating system says enough, no more? Then this may not behave the way you expect. Also, that thread might be allocating resources that are not necessarily going to be easy to collect on the garbage collector. So if that thread crashes, you may have some trouble. And also, what happens if the function throws an exception? Will I get to see that exception in my calling code? I don't know. Let's find out. Let's do that right now. My favorite exception, invalid operation. Okay. Well, this is cheating a little bit. Visual Studio stopped. Let's see. I believe if we went in and I'm not going to do it right now. If we went in and ran this thing from as an exe instead of running it. Oh wait, let's run it. No, what am I saying? Let's run it without debugging. Okay, so there we are. The thread itself barfed up, and the original thread kept going for a while, and then the whole thing crashed. But without me elaborating any further, you can see that because the outer thread kept going, there wasn't going to be any way to catch and handle the exception from there. So that's probably the quickest thing that'll bite you hard when you start using your own threads. Let's go to the next variation. Figure this out, save that for later. Let's go to update status thread pool, and I'll just quickly run this one. It's very similar, a little bit different because in C# anyway, you have to give it what's called a wait callback. Okay, so now instead of just creating the thread myself, I tell call the queue user work item method, a static method on the thread pool class, to say I want to run one of your threads, and I give it something called a wait callback object, which in turn is constructed out of a function, which here I'm just using the same lambda expression as before. So let's try running that. Okay. All right. So that's the threading, the use threads, use the threads loop approach. Let's go now to the next one. Okay, asynchronous delegates. This was also in .NET 1.0, and very few programmers, in my experience, have ever written their own code to use this, written their own providers of asynchronous delegates. Mostly, when you use this technique, it's because you're using some API or other from the .NET framework that uses it. And in .NET 1.0, this was all over the place. Anytime you had something like the file system or HTTP requests or ADO.NET, where you would be doing things that could take a lot of time, there would usually be two different versions of the same method. One would be a synchronous version and the other would be an asynchronous version. And the asynchronous version you could always recognize, or you're supposed to be able to always recognize, because the name of an asynchronous version of something is always supposed to start with begin. And then begin followed by whatever the synchronous version would have been called. Okay, and then there's always a companion method to go with it called end, and the same thing. Okay, and you always need to start things off by calling begin, and you always need to finish things off by calling end. Okay. Now, what this gets you primarily is that instead of just calling a single thread or a single thread pool, making one call in there saying run this function, and I'll figure out somehow what to do with the result. Well, let me back up. Another weakness that I didn't mention before about the threading idea is that it's not so obvious what you're supposed to do with the results. Okay, there is no way to get a return value back from the thread function that you pass in. Okay, always the signature of it needs to return null. So this solves that problem by saying that in the end part of it, there will be a callback. There will be a callback function in there, which will be called by the thread or whatever it is that you start with the begin version, and that callback will be passed a parameter that will have the results in it. So that way you can have the benefit of asynchronous operation and still have a way of getting the result back. This method is much more flexible than the previous one in terms of than the thread-related methods, in that the signature of the function that you're actually executing, the synchronous version, which your beginning and ending are going to wrap around, can have any kind of signature. You can pass any number of arguments into it, or none, and you can have it return just about anything you want, or nothing. So in that respect, it's much easier. Now, the whole thing is implemented using delegates. Delegates are a special type of thing in .NET, sort of in between classes and interfaces. You can think of a delegate as being like an interface with just one method. Okay? And they've existed in one form or another ever since .NET 1.0, but they've changed. And if you've been following, if you've been programming for a while, this is one of the things you probably noticed in every major release of .NET that's come out. Originally, delegates had to have names. You had to explicitly declare a delegate, give it a name, and then invoke it by name, or pass it into something by name whenever you wanted to use it. In .NET 2.0, that was relaxed, and you were allowed to create anonymous delegates where you just have a keyword, delegate, and you say, here's a delegate, and then you give it a function body to specify what it is, what it does. Then in the linked release, which I have trouble remembering now what the numbering is around that time frame, 2005, 2007, 2008 time frame. I can't remember if it's .NET 3.0 or C# 3.0 or, I mean, the numbers got out of sync. So something 3.0, either .NET or C# or something. But anyway, so I just call it the link time frame. Link is when Microsoft introduced Lambda expressions to both Visual Basic and C#, which in C# gives us the syntax we just saw, and we'll sooner or later be looking at the syntax in Visual Basic as well. And then in .NET 4.0, we get these two types, func and action. And these make delegates even more like interfaces because you can now specify the signature of your delegate without having to give it a body. Okay? And we'll be seeing examples of that. So, even though the asynchronous delegates themselves have been around since .NET 2.0, and even though many of the asynchronous APIs in the .NET framework are exactly the same as they've always been, the syntax for creating delegates that you stuff into them has changed. So, let's look at my humble example of that. Maybe we'll switch over to the VB example also. If my computer doesn't freeze up. Okay, so here is the asynchronous delegate method. Okay, now, as I said, most programmers don't create their own asynchronous delegates, but there's no reason that you can't. It's much easier now than it used to be. So I'm actually creating an asynchronous delegate that wraps the getNewStatus method. Okay. The way I'm doing it is by using this .NET 4.0 structure here of func, which is parameterized by the type string. So if I just write func bracket string, that means a function that returns a string. Okay. The last type that you put inside the brackets is always the return type. If there's more than one type in there, then everything before the last one is an argument. Here there's no argument, so I'm declaring that getStatus is a func bracket string, and then I'm going ahead and assigning my same old lambda here to its to implement it. So this is in fact a delegate, but the way I'm expressing the type of the delegate doesn't necessarily commit me to any particular implementation. Anything that takes no arguments and returns a string can be a func bracket string. So once I've got my delegate here, then all delegates have a begin invoke method. Okay? And begin invoke method just says call it, but call it asynchronously. All right? Now, when you call it asynchronously, you have to do a couple of things. Well, take that back. Yeah, you have to pass two things in. The main thing you have to pass in is another delegate. The other delegate that you're passing in is the callback. That's the function that's going to be run when the first function, the one up here, gets done. Okay? So what happens inside this callback is, this is a lambda that has an argument coming in, and the argument is none other than the original delegate. Okay? So remember I said there's always a begin invoke and an end invoke. Here's the end invoke. I'm calling it on the original delegate, which was passed in as an argument, telling it to end. Once it ends, it returns new status, which is the return value of the original function. Okay? So I go through all this. Once I have it, then I call update status with it. There's one more argument here, null. I actually don't, I'm forgetting, I'm blanking out what this null represents. It's something I'm not using in this example, so I'll pass on that. Okay, so how many of you think this would be a really productive way to write your code? Anybody following this just fine? Yeah, there's a hand going up. I like it. Hey. A lot of people, you know, so folks can be very mixed opinionated about whether this is beautiful or hideous. In case you're not sure how to make up your mind, let's have a look at it in Visual Basic. Okay, so everything at the beginning, all the preliminaries in Visual Basic are the same as what you've already seen, or supposed to be. Okay, so here's display status, here's Visual Basic's version of lock, here's update status, here's get new status, so on and so on and so on. The two thread ones are just about identical. Oh, except here. Here we see, here in the thread pool, here's the first case where I'm creating a lambda in Visual Basic. Visual Basic decided that lambdas ought to look just like regular functions in subs. So a lambda that doesn't return anything is represented with the keyword sub. And a lambda that does return something is represented with the keyword function rather, down here. Okay? So this is the same code that we just saw in C#. Here's how it looks in C#, and here's how it looks in VB. Okay? Get status as func of string. All right, so that's how you write a generic type in Visual Basic. Not too bad. And this is how we write a lambda. Function, parens, no arguments, get new status name. And then we say invoke, and here's our callback. The callback is a sub, it doesn't return anything, so the nice thing I think about C#'s lambdas is that the signature for a function in the sub is pretty much the same, and the syntax for it is pretty much the same. In VB, because it's VB, you gotta do things the VB way, and that means subs have a different keyword on them than functions do. So here we're calling it sub. Takes an arg, same argument we saw before, and it does the same thing. Calls end invoke with the arg and passes the result into update status. Okay, I will attempt to run the C# example. Let's